This time we're going to be talking about polynomial inequalities and their graphs. Solve the following polynomial inequalities. To solve one of these, the very first thing you need to do is make sure you have 0 on the right hand side. So we're going to subtract 8 from both sides. The next thing that we want to do is completely factor it. So factors of -8 that add up to -2 will be -4 and 2. Go ahead and set each of those equal to 0 and solve. So we have x equals -2 and x equals a +4. These are the points that are going to be our boundaries. Now this says strictly greater than 0. If it says greater than 0, then if I put -2 in here, it would actually give me 0. It can't be equal to 0 because this says it has to be strictly greater than 0. Because of that, I put a dashed line here just to remind me, hey, look here, do not include these points. The next thing that I want to do is pick some test points. Something to the left of -2. Let's try -4. Something between -2 and 4. Let's try 0. Something to the right of 4. Let's try 6. It doesn't really matter what number you choose as long as it's in the correct interval. Alright, the next thing that I want to do is plug in each of these numbers into my polynomial and see what kind of sign I get. So let's plug in a -4. If I plug in a -4, I will have -4 squared minus 2 times -4 minus 8. It gives me 16, but I really only care about the sign. It will be positive. I think I need a different color, don't I? There we go. So what if I put in a 0? Well, that one's pretty simple. This is 0 and this is 0, so I'm left with -8. But I only care about the sign. Then I put in a 6. If I put in a 6 again, I get 16, which is positive. Okay, this says greater than 0. Greater than 0 means positive. That means I only care about the parts that gave me a positive sign. So that means that my solution set will be everything from -infinity to -2. I do not include this -2, so I put a parenthesis. I pick back up again at 4, again not including the 4, and I go to infinity. This is my solution set. Another way you could come up with the solution set is to look at the graph of that function. This is the graph of the function x squared minus 2x minus 8. You can see that between -2 and 4, the graph falls below the x-axis. This is the area where it is less than 0. So if you look this way and this way, this is where the graph is above the x-axis. That's where it is positive. That's why we wanted to use these two intervals, -infinity to -2 and 4 to infinity. Okay, how about this one? First things first, go ahead and make sure you have 0 on the right hand side. So you're going to add x cubed to both sides. Okay, let's completely factor it. We can factor out an x squared. We'll be left with x squared plus x minus 6. Factor what's in the parentheses. And we will have a 2 and a 3, where the 3 is positive. Set each one equal to 0, and you'll get the interval points 0, 2, and -3. Those are the points that I'm going to be putting on my number line. I didn't mean to include that little equal to under there. Sorry about that. Okay, so we have -3. We have 0. We have 2. Make sure you put them in numerical order. And remember, I put dashed lines because this is strictly less than 0. Can't be equal to 0. So my test points this time, I think I'll try -4. I'll try a -1, a 1, and a 3. So I'm going to put those points in there and see what I get as my signs. So these are the signs that I get. When I plug -4 into this, I get a positive. When I plug -1 into this, I get a negative. When I plug in 1, I get a negative. And when I plug in 3, I get a positive. So looking at the function itself, it says strictly less than 0. That means we only want the parts where this is negative. That would be these two parts right here. So I will include everything from -3 to 2. However, can I include the 0? Well, remember, 0 is one of the zeros of the function. Can the function be equal to 0? It cannot, which means it cannot include 0. So the solution set will be -3 to 0, not including 0, and 0 to 2, not including either of those endpoints. Just like on that last problem, let's get the graph and see what it looks like. Remember, you can use your graphing calculator to get these graphs if you like. Okay, so we want to know where is the function negative. It is negative below the x-axis. So it's negative from here to here. All of this is below the x-axis. And also remember, this point here is where the function is equal to 0. So it cannot include that point, but it includes all of these x values from -3 to 0 and from 0 to 2. Okay, last one like this. This one's already completely factored for us, and 0 is on the right hand side. So we can go straight to setting each one equal to 0. This would tell us that x is equal to -4, -2, and +1. So if we put these on our number line, this says greater than or equal to, which means we do include them. They're already in numerical order. So -4, -2, 1. Now I need to pick my test points. I think I'll try a -5, a -3, a 0, and a 2. So now I'll plug those numbers in and see what sign I get. Alright, after plugging in all of these red numbers, I get these signs. Whenever I look back at my function, it says greater than or equal to 0. That means positive or 0. That's what I'm looking for. That means I want this section and this section. So my solution set will be -4 to -2. I do include both of those endpoints. And 1 to infinity. When I say you do include the endpoint, I just mean you put the bracket. You can never stop infinity, that's why it's always open. Open means you use a parenthesis there. Again, look at the graph. In the graph we have the points -4, -2, and 1. We want the parts where it's positive or 0. So we want here, which is between -4 and -2, and we want here, which is everything after a +1.